Good afternoon. Sorry. Welcome to today's session of our 2025-2026 lecture series Immaterial. I'm delighted to open this event with a few remarks and then hand the floor over. This series asks us to consider architecture's double register, the tangible such as matter, construction, and tectonics, and the intangible such as atmosphere, perception, memory, and cultural resonance. Today's lecture titled Ground Up is presented by Aleksandra Jaeschke. Aleksandra Jaeschke is an architect and an associate professor of architecture at the University of Texas at Austin. Born and raised in Poland, she holds a Doctor of Design degree from the Harvard GSD and an AA diploma from the Architectural Association in London. Aleksandra holds a professional license in Italy when she practiced at ION, an architectural firm she co-founded and co-directed with Andrea Di Stefano until her move to the US. In recognition of the work developed by Aon, she received the Europe 40 Under 40 Award for 2011, conferred by the European Center for Architecture, Art Design, and Urban Studies and the Chicago Athenaeum. In 2013, Aon held a solo exhibition, Eco Machines, in the Museum of Architecture in Poland. Jaeschke was the winner of the Harvard GSD's 2019 Will Wright Prize and the Digital Futures 2021 Mark Cousins Theory Award. She contributed to Log 51 and Log 56, participated in logarithms held in the Italian Virtual Pavilion at the 17th Venice Architecture Biennale, and was part of the Model Behavior, a group exhibition curated by Anyone Corporation and presented by the Cooper Union Foundation in New York in 2022. In 2021, she curated Plant Potential, an event series focused on human-plant relations, a book based on a book based on her doctoral dissertation entitled The Greening of America's Building Codes, Promises and Paradoxes was published by Princeton Architectural Press in December 2022. Please join me in welcoming Aleksandra to the floor.
Thank you so much for having me here. I'm sorry for this one-year delay. This is actually my second time here. I came over in 2019 for the review, so it's really nice to be back. Thank you. Okay, let me just find my way around here. Okay, perfect. So before I talk about my current research, I'd like to provide a little bit of context, say a couple of words about my earlier work and just my interest in general. So as you just heard, my creative work as part of a small architectural studio based in Sicily, Italy, was really strongly shaped by my experience as a student at the Architectural Association in London. ION, my studio, embraced a performance-oriented approach to design, and we really treated natural dynamics as both inspiration and a key driver of decision-making in architectural design. I co-directed the practice with Andrea Di Stefano until 2013, when I moved to the US to pursue a Doctor of Design degree at the GSD. So to give you a sense of what I was engaged in before moving to the US, I'll just very briefly mention a couple of projects. Iramarri was a project for 5 single-family houses located on the coast of Sicily. In Italian, ramarro refers to the European green lizard. In this project, we focused on integrating the architecture with the natural landscape, and the site for this project overlooks a vast agrarian terrain protected for its environmental value, and it's also framed by the mountains on one side and the Mediterranean Sea, so it was a spectacular site. In the project, we sought to give each of these houses the best possible view, while at the same time minimizing its visibility from around and also maximizing the vegetated surfaces. So the Mediterranean maquis, which is really like the chaparral, sustained by collected rainwater, was intended to envelop the dwellings with local shrubs and aromatic plants. The green roofs were designed to protect the houses and accommodate outdoor activities, further extending the habitat. The project, unfortunately, remained unbuilt due to a change in land use regulations. That's probably where my interest in building regulations started. Lost Highway, another design that remained on paper, this time due to the global financial crisis of 2008, another reason for my doctoral research, was a project for a private house, again in Sicily. The building was conceived as a very simple rectangular volume, really a bundle of beams, with an interior courtyard meant to interconnect two independent and flexible living spaces. So it provided us with an opportunity to explore an integrative process that took advantage of the redundancy of that is inherent in glulam in any kind of heavy timber construction. The wall thickness was determined, of course, by thermal requirements, which then in turn generated structural redundancy. And so this allowed us to experiment with integrating other factors such as visibility, illumination, natural ventilation by really subtracting rather than adding parts or layers to the building. We experimented with a randomly generated pattern of openings controlled only really by the desire or desired degree of porosity. And this quite heavily rule-based design approach was in this case combined with a chance-driven process, a combination that I think produced some interesting unexpected results and a distinctive aesthetic. Finally, the last project I wanted to mention is Dome, a brick pavilion that we designed and built with architecture students actually in their second year, which was really great, at the University of Catania, using a revolving compass. And this is a traditional Nubian construction method. The project was conceived as a tribute to the late Italian architect Fabrizio Carola, who employed this tool in many of his community-built projects in Mali, where he worked for a number of years. And so in this project here, you see this compass. We took this traditional manually operated tool that is used for laying bricks, and we gave it another level of sophistication. We made the arm not only extendable, but we also added a mobile brick holder that let each brick rotate around its axis. And so this simple modification gave the tool enough flexibility to actually produce a range of dome geometries and surface effects. And that brought the method very close to what's possible with digital tools today. What's exciting is that this also opened up the potential for countless domes and dome variations to be actually built using the same device that could be reused. And the compass also helped us work with within local economic and technological constraints, since, of course, acquiring at that time and in Sicily a robot was neither feasible, also not really desirable. And so without losing the richness and complexity associated with digital design, we were able to achieve similar effects. In 2011, in recognition of the work that we developed, my partner and I, we received this award from the European Union. And then it was really an exciting time because although it was admittedly really stressful also because of all this legal and economic challenges, but in 2013, we had the privilege of presenting the solo exhibition in Wrocław, which is actually one of the very few museums of architecture in the world. And shortly afterwards, I moved to the United States to really reflect on those years and devote myself to research. So My interest in sustainability originated really in that early creative work, even though the term itself was not really part of my vocabulary at that time. Despite my commitment to the natural environment, I always found myself struggling with how narrowly sustainability was defined within architecture, gradually really recognizing its failure to convey the true hierarchies of importance among our spatial, energetic, and material choices and impacts. And this realization triggered my interest in systems theory, particularly its applications in ecological studies. And over time, I began to really embrace ecology as a framework for architectural discourse. And so, as my understanding of our place within the biosphere became more and more holistic, I also came to see the need to pay equal attention to what we do and how we think about it, to our actions, but also to the mindsets from which they arise. And so up to now, my work has mainly focused on questions that on questioning the validity of the frameworks we use in architecture and on emphasizing the importance of drawing from other domains of knowledge, of expanding our systems boundaries, and rethinking the mindsets that tend to favor certain modes of inquiry over others. At the same time, I've been really constantly deepening my understanding of and appreciation for the relationships that connect humans and plants. After several years of professional practice, I began to realize that the mainstream approach to reducing the environmental impact of construction focused almost entirely on building products. And so form was largely ignored, and perhaps even more surprisingly, the influence of market dynamics and building regulations was almost completely overlooked, at least from my perspective as a practicing architect in Italy. And yet, building technologies, things like HVAC systems, solar panels, windows, insulation foams, depend on a whole set of techniques that support the diffusion and acceptance. And these techniques are just as responsible for the environmental impact of construction as the technologies themselves. So this topic, which is rarely addressed even by academics focused on sustainability, became the focal point of my doctoral research. And since I'm neither a historian nor a building code expert, I approached this tasks from a perspective of an architect, someone whose practice was shaped by restrictive regulations and affected by politics and financial speculation. So in my dissertation, I looked closely at building codes and incentives, two areas that are often considered external to the core of our discipline, yet they are precisely what determines how we actually practice sustainability. And as part of my doctoral research, I examined the historical interactions between the ecological movement throughout the last century, techno-scientific advances, socio-economic agendas, regulatory programs, and architectural discourse to some degree. My goal was to really understand how building regulations and so-called green building incentives shape what architects regard as safe, healthy, and sustainable. And so what I found was that the cultural, socioeconomic, and political forces that shaped those early building codes and financial instruments actually still influence today's regulations and incentives. In other words, those same forces continue to determine how we build, how we measure environmental impact, and ultimately how we define sustainability itself today. The book, based on my dissertation and entitled The Greening of America's Building Codes, was published in 22. And in the book, I, of course, examined the origins of the narrowly defined frameworks and mindsets from which all these ideas, sustainability, green building standards emerge. But at the same time, the book tries to reflect on, and that's for a series of interviews, how we might expand the boundaries of our practice to actually try to catalyze some meaningful change. And so I highlight a range of successful, what I call pre-design efforts, including things like the development of new model building codes and standards, technologies and products, and software tools, but also financial mechanisms. And among others, I spoke with the American architect Martin Hammer about his work on the development of model building codes for traditional construction systems, such as straw bale, and more on that later. And I also spoke with the German geographer Michael Bruce, who developed the environmental simulation software called NVMet, which many of you probably know and use today. So my struggle with the narrowly defined term sustainability also had to do with how we define the spatial temporal system boundaries. So think about this. A relative increase in energy efficiency, for example, might turn out completely insignificant if one considers other scales of investigation. Yet we often draw the boundaries of our, that is, architectural systems too tightly to be able to even see it. And so I have reflected on this issue in several essays, at times in a playful way, as it was in For Here Please, which basically is an essay or an audio piece, really, because it was part of an exhibition in which I use my daily coffee making routine as a lens to examine system boundaries in architecture. And so I reflect on how, through this lens, on how architectural models often fail to account for the social and ecological impacts of building production, as well as the erratic and wasteful behaviors of consumers that frequently really undermine the environmental claims that we make as designers during the design process. In a somewhat more serious essay, The Song of the Banyan Tree, I bring together two ways of thinking about life systems. The first one is the systems ecologist Howard Odum's energy-based metabolic models, and the second is the biologist Jacob von Uexküll's functional system diagram. So Odum's models describe how energy and matter flow through ecosystems, while Uexküll's diagrams show the physiological mechanisms that actually allow organisms to interact with the environment. And by comparing these two perspectives, I reflect on communication as an often overlooked dimension of ecology and on its potential to help us rethink how we respond, how we address the environmental crisis. As my understanding of our place in the biosphere grew more holistic, I came to see the need to pay equal attention to what we do and also to the mindsets behind those actions. And so in my Wright Prize lecture, which was the result of a number of months of travels across various regions in the world where greenhouses are used for agriculture, I use the greenhouse, which we sometimes call as a forcing frame, as a metaphor for the kind of reductionism that often shapes Western ways of knowing and valuing. And so I talk about how this forcing frame attitude shows up in the subsidies and what I call leakages. You would call it those unintended consequences that we tend to push outside the boundaries of our investigations. And economist Ezra Mishran back in the 60s referred to this as external diseconomies, while Herman Daly later on, until recently when he passed away, talked about externalities. And finally, in ground-based variations, I look at how our tendency to see terrestrial surfaces as fixed boundaries reflects what the philosopher Alfred North Whitehead called the fallacy of misplaced concreteness. Drawing on ecologist Susan Simard's research on mycorrhizal networks, mycelium, I highlight the non-human intelligence and interspecies communication that take place underground, and how human cognition itself depends on these non-human cognitive webs and the spaces that sustain them. I also bring in indigenous concepts such as holographic epistemology developed by the Hawaiian scholar Manulani Aluli Meyer, and two-eyed seeing articulated by Mi'kmaq scholars of what's now Nova Scotia in Canada, both of which challenge Western paradigms and invite us to understand soil and ground as far more than just functional substrates that ground section line that we draw in half a second. One of my more recent and still ongoing explorations is entitled The Chakra, a gardening manifesto for architects and the Galapagos. It grew out of a series of study abroad trips with students that we developed over the last 3 years at UT Austin. Now, it's difficult to place this project neatly into one of the categories I mentioned earlier, because it really touches on all of them: the importance of other domains of knowledge, expanded system boundaries, and of course, different mindsets. So in this project, I look at the Quechua concept of chakra, and Quechua is it's an indigenous group from South America, in part today's Ecuador. And what it is, this chakra is a kind of polyculture grown within unmanaged forest, so the Amazon, that provides both food and timber while fostering coexistence with non-human organisms. It carries a nuance that is missing in the Western term agroforestry. So I explore chakra's potential to challenge both the monocrop farming and restrictive approaches to natural conservation, offering or trying to find a model for the Galapagos that, by the way, is growing in terms of population at staggering rates, trying to find a model for them, but also for other regions that face similar issues, such as invasive species and dependence on imported food and materials, and the loss of traditional ecological knowledge. Ultimately, I explore this concept as a land-based practice that could offer a localized alternative to the global system of material sourcing that dominates architecture today. And finally, there is this fascination with plants. The interest first grew out of my really early explorations of biomimetics when I was still a student at the AA, and then resurfaced during my doctoral research when I looked at how building codes deal with vegetation. And so it came to the foreground when I decided to look into the greenhouses as part of my Wheelwright Prize research. And so to continue that work, I realized that I really needed to develop a deeper understanding of plants themselves, but also the complex relationships that we have built over the centuries, if not millennia, between plants and humans. And this is what I focused on in this project called Plant Potential, which is actually available as an educational website. The project included a series of conversations that explored plant life and human-plant interactions, but also a conference that brought together various creative efforts and creatives who try to recover the often forgotten knowledge and the wisdom that plants hold. So today I'd like to give you a sense of what I've been thinking about lately and how I've been approaching it. The topic is straw bale construction, but it's really part of a broader investigation into the rich landscape of biogenic materials, something that has become very present and popular in our conversations in this period. And I myself currently teach an advanced seminar on this topic. What I will share with you comes from an essay I'm currently working on, which will be part of a book I'm developing. It's a collection of loosely interconnected essays that grew out of my Wheelwright Prize research. So at some point, I was invited to contribute to a book that explores architecture as a form of environmental media. And I was already at that time researching straw bale construction, but that prompt opened up an additional, really to me, interesting angle for my investigation. So I began to think about, all those visual tools that we use to talk about environmental impact, maps of resource extraction sites that expose the hidden consequences of construction and reveal the influence on ecosystems and human communities, all those diagrams of fuel use and CO2 emissions that help raise awareness about the environmental footprint of buildings. Of course, all these tools are incredibly powerful. They help designers, policymakers, and activists develop arguments and communicate decisions across scales, from clients to authorities. But they rarely show the full picture. Most of the time, they address only part of the planetary problem, and especially in the case of a material that's a byproduct, like straw, where impacts are usually assigned to the primary crop, in this case, wheat, these diagrams often fail to account for the material's full lifespan. There are a few different ways to calculate these impacts. Under the zero burden approach, we only count the impact of baling, transport, and use, none from growing the crop itself. So straw appears to have extremely low embodied carbon. With economic allocation, straw gets a small share of the growing impact, still low carbon, but slightly higher than if you use the zero burden approach. And under mass allocation, straw is assigned half or more of the growing impact, which makes its embodied carbon much higher. We rarely do that in our field. And we often see negative carbon emissions reported for these kinds of materials since they absorb carbon as they grow. In other words, we get credit for work we humans did not actually do. But more on that in a moment. By the way, those are diagrams from a phenomenal book by LTL Architects, the biogenic house sections, highly recommended. But as our investigations over the last decades, years, into the environmental impact of buildings have expanded, or we could even say shifted, from an early focus on the operational stage to a full cradle to grave perspective, and now with even more focus on the raw material supply chain and then the end of life of materials, of course, as well, which is not at the moment the topic of my talk today, we've started to look at a much bigger picture. And I like to use the framework of the 9 planetary boundaries to think about this broad and at times rather bleak picture. This framework was developed and is continuously being updated by the Stockholm Resilience Center. It identifies 9 key planetary systems that together indicate the overall health of our planet. By the way, there's a phenomenal documentary about this. I really recommend it. Its title is Planetary Boundaries. And so what's included among these systems or these issues is climate change, biodiversity loss, or what the framework calls biosphere integrity, land system change, freshwater use, biochemical flows, that would be nitrogen and phosphorus cycles, of course, ocean acidification, stratospheric ozone depletion, and atmospheric aerosol loading. Those are all these airborne particles such as dust, smoke, chemical pollutants that basically scatter sunlight and affect both the climate and air quality. And then there is chemical pollution, also known as novel entities. Just think of plastic, all the synthetic materials we've been introducing into the natural environment. So all these visual tools and methods we use help us talk about environmental impact, and we can definitely do even more on that, but I think we've been already paying a lot of attention to it and using these tools in quite successful ways. But at the same time, buildings themselves convey environmental messages in very different ways. And there's a long history of environmentally conscious design that not only tries to reduce a building's impact, but also uses architecture as a form of communication, as a way to express environmental values. And we could say, in other words, that buildings also function as environmental media. But whether these two objectives, the actual performance and the message being communicated, truly align, I think is often debatable. Sometimes and often unintentionally, most of the time really unintentionally, architects project messages that are only true in relation to maybe more harmful alternatives or within narrowly defined system boundaries. And so these messages may be based on practices that were considered environmentally friendly in a different context or at a different time. But once broadcast, these messages tend to perpetuate themselves. So let's take a closer look at straw, since it's often held up as an example of healthy and environmentally responsible construction. And I still think rightly so for many, many reasons. In the United States, the practice of building with straw began to take shape in the late 19th and early 20th century, especially in Nebraska, where settlers in the Sandhills used straw to build their homes. By the way, the most famous, I think, example is the Pilgrim Holiness Church in Nebraska that is almost a century old. Now, my own engagement with straw began when I was a doctoral student, so that's a while ago, at the Harvard Graduate School of Design, where I led a project to help a community in North Dakota, an indigenous community, develop a new housing prototype. So as part of the preliminary research, we evaluated 6 different construction assemblies and ultimately chose non-load-bearing straw bale construction. Now, despite its many advantages, low embodied energy, local availability, and the community's prior experience with this construction technique, implementation was challenging, and it was hindered by the lack of logistical infrastructure, but really mainly by cultural misconceptions about straw as a building material. So let me give you a really quick overview of this project. So to propose a solution, we began by analyzing 6 common wall systems and 1 typical foundation, since there isn't really that much to choose from. So we could compare their performance and environmental impact. We modeled and analyzed each of these systems to see how they performed in 3 key areas. Overall mass, which of course matters when assessing the impact of transportation, energy, a more inclusive way of thinking about embodied energy that was developed for really ecosystem accounting in systems-based ecology by Howard Odum again. And we also looked at heating loads to just understanding the energy required during the operational phase. So here you see an exploded diagram of a solid wood system and the diagrams of its scores. And going through the different materials, this is a straw bale, non-load bearing straw bale construction, SIP panels, light gauge steel frame with rigid insulation, wood frame with batt insulation, and then passive house. Of course, even just visually, we see how things start to expand. We then looked at the supply chain and evaluated how the mass of each material relates to a distance it needs to travel to actually reach the site. And this helped us assess the embodied impact of transportation, not only in terms of energy use and carbon emissions, but also just simply to acknowledge, even if not being able to quantify it, the hard to measure effects on road infrastructure and ultimately on land systems. So in these map-based diagrams, you can see each system analyzed in terms of the distance its materials would need to travel from the first supplier that we were able to find. And the thickness of each line represents the mass distance impact, and the gray circles show the energy or the embodied equivalent of embodied energy for each material, and the orange one shows the cumulative impact for the entire system. So again, it's comparing the same systems, solid wood, straw bale construction, SIP panels, light gauge steel frame with rigid insulation, wood frame with batt insulation, and passive house. Now, these 2 types of analysis helped us narrow down the options. There wasn't a simple, clear winner, but we focused on 3 systems for a moment. It was the SIP panels for the lightness, solid wood for the low energy, and straw bale for the really local availability, proximity to the site, which of course affects the transportation. And even though the passive house system offers, with no surprise here, clear advantages when it comes to operational stage, among the three shortlisted options, straw bale construction really ultimately outperformed both solid wood and SIP panels, considering all these issues. But the decision wasn't really based on performance alone. The site and the community are located in an area where straw is abundant. And so the yellow areas on the map here, of course, indicate the crop producing regions. And some of these are tribal lands, the ones in black. And that makes this really important because it creates an opportunity for intertribal collaborations, we could say. And also importantly, we discovered that the community had some previous experience in straw bale construction. Nat Quorum, who works a lot with indigenous communities, had organized a straw bale workshop there. And so many community members we spoke to had taken part in it and still retained that knowledge. So we felt that this was also a very important aspect to build on. And lastly, the community had an abundant workshop with full of tools, remnants of a business that had failed, if I remember correctly. So we wanted to see whether we could also help them build an economy around the construction system itself. So we suggested that while they build their homes in a simple way, just using straw as an infill in a common stud frame that is much easier, they could also in parallel develop a small prefab system that is similar to one, for example, like what the Modsel company in the UK does. And you see it here in the picture. That system could eventually be sold, helping the community not only to resolve the issue of housing for themselves, but also somehow create a source of financial security, which is another issue that they face. Unfortunately, as I said, the project was eventually archived by the community's new leadership, and the reasons were many. But cultural preconceptions really, I think, were the key one. Simply speaking, straw in a farming context is still very often seen as a poor man's material. I later explored some of these issues in my book, reflecting on the role that legal frameworks, industry standards, and building codes play in shaping how we value or devalue certain construction systems. As I mentioned, in part this was something that I explored through those interviews, and it was really interesting for me to see how this construction, which largely disappeared with the rise of industrial materials, like most of those traditional systems, actually reemerged in the late 80s, partly in response to California's efforts to curb the burning of rice stalks. So it was a pollution issue. It wasn't really related to construction at that time. And so around that time, straw bale construction was actually rediscovered as a natural low impact alternative and a way to use that straw and not burn it. And it began to attract renewed interest as a healthy building material. And the advocates like Martin Hammer, whom I interviewed, have since worked to integrate straw bale construction into building codes, actually moving it from those legislations related to air control, air pollution control, and in order to help to legitimize its use in contemporary architecture. And so now in many cities and states, we actually have a straw bale appendix, which we didn't before that. All these earlier experiences made me deeply interested in the potential of straw bale construction, and I still am to some extent, but at the time, I had not really questioned where straw actually came from. So last year, I decided to take a closer look. And in the spring 24, I took part in a workshop organized by strawbale.com, which is a really interesting organization that supports straw bale construction. And I gained new insights into the current interest in this material. And the experience helped me understand who is drawn to this construction technique and really why. So part of the appeal comes from its status as a byproduct. and essentially a waste material, something not extracted or harvested on purpose for construction. That idea is very strong. It's praised for its ability, of course, to store carbon, a quality that has also fueled enthusiasm for many other biogenic materials in recent years, often without questioning the exact meaning of that term. Many participants also spoke about the health and general well-being benefits, the tactile simplicity of the construction process, and the satisfaction that comes from working so directly with an organic material. Many of them talked about it. They also emphasized the sense of community that comes from the collaborative nature of straw bale construction, especially its owner-built projects where friends and family often actually take part in the building process. So also last year, my students at UT had the opportunity to build with straw, and the material came from a nearby farm. It actually wasn't that far from Austin, where straw is a byproduct of grain production, which here in Texas means wheat straw, which is the most common type. It could also be rice, rye, or oats. The bales that we used were very clean, of course, and clean enough to handle with bare hands and light enough to move around and without any kind of heavy machinery, which is incredible. The urban farm that hosted our project planned to repurpose the leftover straw as mulch for their crops, closing the loop in a simple but meaningful way. The wall we built was finished with a plaster sourced from a nearby riverbank, which we applied by hand. The process itself, breathing in the scent of straw, feeling the texture of the clay, created for students a deep sense of immersion in both the material and the environment. It became an experience of attunement, a moment of realizing how a construction material can foster a more intimate relationship with the land. And then I drove to Kansas, the second largest wheat producer in the United States. The journey from Austin took me through the vast open landscapes of northeastern Texas and across the plains of Oklahoma. Fields stretched endlessly on both sides of the highway, barren expanses awaiting the planting of wheat or corn for animal feed. I found myself fixating on the muted shades of brown and green, the perfectly straight horizon line that you know so well, the idle irrigation arms, and the occasional solitary tree punctuating the landscape. At one point, a dust storm swept away the road, across the road. It took me 2 days to reach my destination, Salina, Kansas, though I could have easily kept on driving north all the way to North Dakota, which produces even more wheat. But Kansas was my destination for a reason. It's home to the Land Institute, an organization devoted to reimagining agriculture beyond the monoculture farming of annual crops. Wes Jackson, who you see here in the picture, the founder of the Land Institute, 1976, I think, has long advocated for a shift towards perennial grains and polycultures, a bit like that chakra that I was talking about, that in this case mimic native prairie ecosystems. So I chose Salina as my vantage point, a place from which to re-examine straw as an environmentally friendly material. Now, of course, industrial farming presents countless environmental challenges. Soil depletion, loss of biodiversity, groundwater over-extraction and pollution, and of course, a growing vulnerability to dust storms, which have become more frequent as climate change accelerates. We all know this. In the face of rising yield expectations and economic pressures, industrial agriculture has been pushed far beyond ecological limits. As economist Herman Daly, but also the ecologist Howard T. Odum, who I mentioned, both pointed out the hidden subsidies embedded in the system. The fossil fuels that power tractors, fertilizers, and irrigation networks, subsidies that make large-scale monoculture appear efficient and affordable, but only by externalizing its true ecological costs. But another consequence of this continuous push to optimize harvest efficiency and increase grain yields is that over the decades, genetic modifications have also shortened wheat stalks. The once tall fields I remember from my childhood, where one could just get lost and disappear among the fields, are vanishing. And for architects who hope to use straw in construction, this poses a growing challenge. Many farms now produce too little straw for small baling to be actually economically viable. It's actually very hard to find them. Regenerative farming, with all its limitations, since of course it still relies on chemical inputs like herbicides, tries to address some of these issues by promoting, or some of the issues that we criticizing in industrial farming, by promoting, of course, soil health and biodiversity. But one of its practices is to leave the straw in the field. So from an ecological standpoint, that makes perfect sense. Straw plays a vital role in returning nutrients to the soil and in sequestering carbon. But this, of course, works against architects. The very argument that makes straw bale buildings so appealing as carbon sinks is complicated by the fact that, ecologically speaking, that carbon might actually be better stored in the ground. West Jackson's Land Institute goes beyond the goal of regenerative agriculture. Its mission is to transform monocrop annual farming altogether. And so the aim is to develop perennial grain crops grown in diverse ecosystems, essentially mimicking the structure and resilience of natural prairies. And this kind of paradigm shift challenges the very foundation of straw bale construction. But the benefits of a transformation of this magnitude, ecological, social, and planetary, far outweigh the loss of one niche biogenic building material. Honestly, I'd be happy to live without that. Perhaps Kernza, a perennial grain developed at the Land Institute, will offer an alternative kind of straw one that we could eventually test for its material properties. But what matters more than having a new construction grade straw is what Kernza represents, an alternative to the monoculture that lies at the heart of industrial wheat farming. And large-scale industrial farms do more than just diminish biodiversity and exhaust the land. They also sever the deep reciprocal relationships between people and the landscapes they inhabit. When fields stretch for miles with only a single crop, genetically uniform, chemically sustained, and mechanized from planting to harvest, the land becomes an abstraction, a resource to be extracted rather than a living system to engage with. Farmers become managers of inputs and outputs rather than stewards of diverse ecosystems, and the plants themselves are treated as industrial commodities instead of participants in a complex web of life. Monoculture fields lack the variety, the richness, and the seasonal rhythms that foster a sense of belonging. They don't nurture the kind of knowledge that comes from working closely with many different species, knowledge that is tactile, intuitive, and deeply ecological. They do not encourage the kind of intimate place-based practices that sustain both ecosystems and cultures over generations. In contrast, polycultures, like those envisioned by the Land Institute, but also like the coffee chakras I spoke about before, offer the potential to restore not just ecological health, but also our human connection to the land. They create opportunities for collective knowledge sharing, from seed saving traditions to soil restoration practices, helping ensure that agricultural wisdom is passed down through generations. In this way, polycultures don't just support biodiversity in the fields, they also sustain the social and cultural diversity that makes agricultural landscapes feel inhabited, meaningful, alive, and cultural. A monocrop plantation, by comparison, such as a wheat field from which most straw is derived, can never make one feel native to the land. It's too uniform, too rigid, too indifferent to the nuances of place. And unfortunately, that's the unwanted part of the story of straw bale construction. It's the same story we are now witnessing with timber, where tree plantations, monocrop tree plantations, are so often portrayed as forests. And so even though a landscape like the one you see in this slide might evoke positive associations, that of abundance, harvest, bread sharing, all these cross-cultural symbols of plenty, it also points to something darker. It indexes processes of overexploitation, soil depletion, water overextraction, pollution, the disruption of nitrogen cycles, and quite simply, the continuous expansion of land under cultivation. We could and we should start accounting for more than just carbon and energy. We should begin to chart embodied water. And last but not least, we should ask, echoing back Mr. Fuller's question, the one asked to Norman Foster, how much land do our buildings take? How much land do we occupy and how much soil do we exhaust in order to extract, grow, and harvest the materials that make our buildings possible? Climate change, of course, but also biodiversity loss, land system change, freshwater use, and those biogeochemical flows, that's the nitrogen and phosphorus, are all central to food production. Then there is, of course, also ocean acidification and all the other systems mentioned in this framework. Each one of these systems, more or less directly, is affected by agriculture and therefore influenced by every building that uses straw or any other biogenic material, supposedly healthy and sustainable material. And so it all depends, and there's a lot to think about here. And so to go back to my initial explorations, straw bale construction emerged really as an alternative recently in response to a very specific environmental challenge and opportunity. And that was the need to address the burning of rice straw in California. I think it was a pretty interesting solution that they came up with. But claims about its environmental benefits shouldn't be seen as universal or permanent. And recently, I had a fortune of meeting the environmental historian Donald Worster. And during our conversation about sustainability, he asked a deceptively simple question: sustainable for how long? That question has stayed with me. And I think the temporal dimension is something that we often overlook. We are always working against a moving target, it's not a fixed, done deal. Ecological systems shift, economies fluctuate, issues change, and knowledge evolves. And our decisions must be continuously reevaluated. And so the messages our buildings project should be grounded in their spatio-temporal reality, attuned as best as we can to the land and its rhythms. In other words, when we use a material, when we make claims about its environmental neutrality, we have to learn its whole story. Otherwise, it remains a straw story, one that barely holds together, one that, like loose straw, can be easily blown away. Thank you.
So much, Alexandra.
Thank you.
So I want to open the floor for the questions, and also I want to ask the online attendance. Also, if you have any question, you can also put it in the chat box. So any questions here from the floor?
Hello. Thank you very much for your presentation. You mentioned natural dynamics, as in the redundancies in the glue lam and the flooring, and how that might look as walls and columns and apertures. And I was wondering if there's any natural redundancies in like straw or in building materials, and how we might use that to design.
Let's think about how we analyze the natural dynamics to decide what material, what biogenic material can be used in construction, if it's suitable, right? So I think, for me, what's really important is, should I do something there?
I think so.
It's better if I sit
Yeah.
Okay. That's fine. That's fine. So I think what I'm trying to say here is that there are two sets of issues that we should be considering. So one is something that we've been doing for decades, and analyzing a material from the point of view of its appropriateness for specific climate when it comes to using it there. So in terms of temperatures and humidity and all the things that affect how a building can modulate climate. And so it's about comfort, right? It's about how materials perform and behave, for example, in a place like Houston versus a place like North Dakota. And so if you're thinking about that, there are, of course, decisions to be made. And perhaps in certain climates like Houston, it's not really appropriate to use straw bale unless you really work very much on sealing it. And still, you can do it, but it's more risky. On the other hand, what I'm interested in is really expanding this analysis beyond the building itself to understand how the origins and the entire cradle to grave process of using a material, extracting it, and then disposing of it, how that affects not just the performance of the building, but the health of the environment. And so then, as I mentioned in the project that we worked on in North Dakota, what we were interested in was, for example, the availability of the material locally. So in Austin, where I come from, I teach students about bamboo, but would I suggest building with it there? No. But I want them to know it because they might end up working somewhere else, right? So that's one thing that is very important. The other thing is really, recognizing what's out there in terms of skills and helping people use local skills so that you don't have to, for example, travel with an entire crew to build a 3D printed building somewhere where you could build something using local labor. And perhaps, those are ethical questions sometimes that to me are equally important. And then there's this massive questions about planetary health, where if you will, if you're willing, ready to acknowledge that and question it, then we're talking about constantly being alert when something is labeled as sustainable, to really keep on assessing it and do it in relation to specific context, because the situation will be very different if you're in the middle of the fields and you have that surplus of material that is not going to harm the situation, and it's already happening. But it's a whole different story if you start to transform a landscape into a field of hemp, right? For example, to create a new building construction system. So I don't have one answer. I think what I'm trying to do is, at least with my students, to help them think about this problems on case-by-case basis, and also be very honest and very open about what should be considered, and to consider as much as possible. I'm sorry I didn't quite get the beginning of your question, but I hope that answered it. Now everyone is going to be scared to ask.
Hello there. I just wanted to know, so you posed this this question, or rather the one who told you the sustainability, well, sustainable, but for how long? Do you kind of foresee sustainability in architecture as something that in the future buildings are going to become more and more ephemeral and more easily replaceable, rather than something that is going to stand there for ages and ages? I just kind of wanted to know your thoughts about that.
Yes, I honestly really have always struggled with how we try to standardize those best practices. And as much as I see a lot of value in all the different systems or labels, let's say, the USGB, United States Green Building Standards, LEED, or anything you can think of, they really help us think through those issues. And I think they help define methods. But as I said, I don't think it's something that we can standardize and fix it, both in time and space. And so I would really want to see them used as a starting point. as opposed to a landing place where, you know, it becomes a plaque and we can congratulate ourselves. That bothers me and worries me a lot, because as I try to, you know, explore today, these things just really change, and I don't think there's one answer. But it's also true that many of the systems keep on evolving, and they are becoming more and more complex, more and more flexible, but it's a hard thing, because on one hand, it's very difficult to start evaluating things and even establish your own framework every time you do a project, right? So you need something that can help you through this process. But on the other hand, the situation is never the same. So it needs to be adapted and adjusted.
Thank you.
Hi, thank you for your lecture. I just wanted to quickly talk about this, and you might have mentioned this, but I want to kind of double check on my understanding on this. So, straw bale, the material, I was curious about how it interacts more with ground conditions, how it's
How it interacts with what?
with the ground condition.
Ground condition.
Yes.
In the process of building.
Yes, because I saw the pictures in your lecture and how it was assembled and how it was structured. But I was wanted to kind of clarify in my head more about how that goes, because I was thinking about this material and how it could handle like moisture problems or handles.
You know, that's has been really resolved in the sense that we use typical foundations, mainly because we can't use other foundations, right? Like building codes just allows you to use one plus helical pier foundations, which actually we looked at. I didn't talk about it, but so once you have a foundation, and the only thing that needs to happen is that the straw has to be really well protected from the humidity that potentially rises from the foundation. And we have all those techniques. And so it really is about sealing it properly and making sure that it's protected, because it should not be exposed to humidity. But that is described in all these appendices. And actually, initially, the way building codes treated it was very much kind of trying to mimic the systems we use in the typical layered system. And so they would impose all different layers that people who knew straw bale construction thought were just superfluous, and they actually worked against it. They like sealed it too much. So then they acknowledged that and simplified it. So now the system is much simpler, but it still needs protection. So you'll see special layers, especially when it comes to the foundation, to make sure that it doesn't absorb that humidity. Yeah. But it's the same like with timber. You can't just put a timber post right directly in the soil. It has to be raised and it has to be protected. So yeah.
All right, thank you so much.
You're welcome.
We had a question over here real quick.
Hi. Yeah, you mentioned that you are kind of working on changing building codes and making them greener, and I was wondering what kind of challenges you face with that, with this kind of vernacular, because I mean, I imagine every area would try to do something different, and specialized for that area. So in terms of standards, how do you how does that work, and what challenges do you face?
Are you talking specifically about straw bale or like different materials in different places?
Straw bale and also different materials. Yeah, how do you deal with those challenges when working with adjusting standards and building codes to allow that type of thing?
So in terms of straw bale in the States, the places where you can actually build using straw bale construction, they share pretty much similar standards that are collected in that appendix, that is a straw bale appendix. And of course, they will be, you will be looking at different thicknesses, additional insulation, depending on where you are in the world in terms of temperatures, but they are very similar in that sense. So I don't, that is also something that, you know, you will find similar techniques in Europe, but because if there's a lot of flexibility, there's like two main systems. You have the non-load bearing system that uses a frame, and that frame can be many different things. So depending on the, you know, local tradition, you could use straw bale as an infill, adapting it to different frames. Or you can use the Nebraska style, which is a load-bearing system, but that one is very rigid because it doesn't allow, you know, it's just like one floor and very limited openings. It's just much more restricted. And so it's in the States, you know, just because of the nature of the, like the degree to which we standardize things, it's pretty much similar, but it's also positive in the sense that the communities across the country actually share a lot of knowledge. And wherever, you know, in one city where they decide to adopt this appendix, they might be looking at a similar climate where it's already working. And so with little tweaks, these things are just adapted locally. But in other places, like for example, when we were in the Galapagos with students, it's just a whole different set of issues because they hardly have building codes. You'll be surprised, but they're just so basic that you see construction sites that would never happen here. And so there's on one hand way more flexibility, but also much more resistance when it comes to using certain materials because there is such a push for concrete construction that is considered the modern construction that they aspire for. And so even, you know, when we're talking about like recycling plastic and trying to help them think about how not to send all the waste to the mainland, which is far away, and recycle it on the islands and turn them into bricks, they were very reluctant until we started talking about perhaps printing natural patterns on them so that they resemble something that they're familiar with. And so the issues are just very different. And by the way, that's what they use now when they build in the parks. They build like paths or stairs. They don't use timber. They use this plastic that is basically like stamped with timber pattern. But there's no rules there, so it's really what works gets, you know, is kept, and what doesn't work just disappears. So it depends, yeah.
Thank you.
Thanks, Alexandra, for a wonderful presentation and particularly for sharing a range of projects and research and teaching. I have a question about how you navigate that systems complexity, because what you've spoken about so often is about individual materials, but then all those connections to economy, to culture, to location, to regulation. Yeah, how do you know if you found a solution? I guess is another way of doing it, because you could.
I haven't.
Where does it stop? You have a deadline, or you have to submit.
I suppose you're not asking me how do I know I found a solution, but how do we know when we found a solution? I think it's a bit of an ethical question. I don't think it's a number question. At some point, you know, when you evaluate different options, you know you've evaluated enough to a point where you actually feel comfortable that you've done the most you could have done. And so maybe it's not going to be perfect, but it's going to be better and more inclusive than would have been done without this research. And I think that's what we try to do in North Dakota, try to look at so many different aspects that pushed us towards a construction technique that wasn't as performative in certain terms as, you know, SIP panels were, but we thought it was holistically responding to more issues. And so I myself ethically felt comfortable to suggest that. But could I put this in numbers every time? No.
I have a question. I have the mic over here.
Oh, here.
So I'm really interested in like the issue of like how as architects we can use our skill sets to kind of combat monocropping cultures, and so like as you are doing, and so like I think of mapping representation as one method, right? But that seems more about communication, collaboration rather than being active. And we have material investigation, sort of how you're doing with the straw. But you also mentioned how potentially it's better to just leave the straw as a carbon sink and just let that do its own thing. So I'm thinking of like the potential, like taking our main, I guess, specialty as architects in form. So do you see any way that design that we can apply architecture as a mechanism to fight mono cropping, or is it more about the other methods?
I think what I'm really interested in, especially considering how our discipline is evolving, you know, with AI, with all these new tools, is how we can leverage more and more the design thinking across scales, across domains, be that kind of a catalytical force that can reveal these dynamics, help analyze these dynamics, and really bring together people who normally don't speak to each other, don't talk to each other, like construction people and farmers, and see the opportunities in those systems. And so I think architects are really well positioned to do this kind of work. It doesn't mean necessarily always designing, but it's really helping people figure out what opportunities are out there if you put people together and think not just about food or about building materials, but think about them together. Did that answer your question?
Yeah, so I'm sort of
Kind
taking
of.
relationships, the relationships that we have as architects, if we could be our main force.
Yeah.
Thank you.
So thank you so much, Alexandra. I want to go back to your book that has been published with Princeton Press. And I was curious when I was going through the book. So I learned more about the building codes, especially in the North American context, and especially how we can think about ecological measures as the bureaucratic checklists. And I was curious to learn more, especially from your experiences based on, you know, the beginning part of your presentation and your projects in south parts of Italy and also in the Europe. So how would you compare in terms of the regulations, the North American system of thinking about the building codes and green building codes with the European one? Do you have any, feedback or specific perspectives about that one?
So the building code in Italy where I worked was much thinner. I was shocked when I started doing this research and I ended up with that much paper on my desk. It was really overwhelming. I think the construction here is way more standardized and it's much harder to design things that are custom designed with pieces, you know, technology developed for a specific project. I think that's still much easier in other parts of the world, although in Europe that process is happening too. So things are changing and it's going to be different in different parts of the world, of Europe. But so that I think sometimes creates opportunities for more creativity and more innovation in architecture. It's just there's more flexibility. I think we see that in South America where there is a lot of work that is phenomenal, and in part is because it's still possible. On the other hand, Europe has very stringent environmental regulations, which you all know very well because you're from there. And that is also common to the entire European Union. And that's advancing, and I haven't lived there for now 13 years, so I don't even know where exactly that is. But I think that they're really trying a lot to do a lot to not only limit the impact of buildings, but often actually think about it regionally much more. So like if you think about what Switzerland is doing, it's going to be well, that's not European Union, so they're very independent in that sense, but it's often really looking at macro regions and water basin based kind of regions and trying to see what makes sense in those places. So yeah, it's kind of a mixed situation in that sense.
Thank you so much. I think
Thank
we
you
can
for
call
having
it a
me.
day.
Thank
Thank
you,
you so
Peter,
much,
for being-
everyone, for joining us.